Okay, folks. I'm back once again. Today, or right now, looking at maximum arrays, a Python exercise from Codewars.com. This is another code breakdown. In this one, you're going to be given an array of unique elements, and your task is to rearrange the values so that the first max is followed by the first minimum, followed by the second max, then followed by the second minimum of value, etc. So, looking at this example, you have an assortment of integer values, and the result is the maximum followed by the minimum, then the second maximum followed by the second minimum, and then what's left, because there's only one more value left. So the items in the list must be rearranged such that you begin with the first maximum number, then the first minimum, second, and so on. So that's what it is. And as we scroll down, and that's just an explanation, and that's it, folks. So it's just find max, find second max, second min, so on. Let us get in here. I'm going to create an empty list to hold my result in. And the strategy I devised for this one is I'm going to use the pop function of lists to extract the maximum and minimum, put it into this new list, loop around and do it again, because and I'll do that until the items are gone. Because if you remove the highest number and the lowest number from the original list, you loop back around, the highest and lowest are gone, so then you can find the second highest and the second lowest. You remove those, then you loop back around again. So that kind of solves the problem pretty well, because to find the second max or min, the first ones have to be ignored, and if they're taken out, they're not considered. So it works out. And I'm going to do the removal until there's no more items left in the list. So while the length of the original list is greater than 0, I'm gonna keep looping. And what I'm going to do in this loop is, this is kind of a fail-safe to avoid any problems. I'm going to use exception handling as a device here. I'll just type this up real quick. Yep, that's quite a mouthful there. What I'm doing here is I always say when you're confronted with a complicated expression in programming, you look from the inside out. So I'm getting the max of the original array, of course the maximum, the current maximum. Then I'm getting the index of that maximum in the array. Then I am popping that value, so I'm finding the max, getting the index, taking it out, and then I'm appending it to my new list. So yeah, all that happening. Find the max, remove it, and then append it to my new list. So on the first iteration, I'm going to be getting the first max. And I'm going to do the same thing for the min. So get the max, get the min, and my accept is going to be if really if there's no items left. So once I do the, really for either of these, if they raise an exception, then I'm going to do this accept part, and the accept part is simply to return, because at that point these instructions are going to raise an exception if there's nothing in the list. And if there's nothing in the list, I just want to return what's there already because I'm done. So it's kind of a fail-safe to keep from having any problems. And but if I'm able to complete all the pops, the list will exit, and then I can simply return the list. So if I run out of items inside the loop, my accept is going to handle it. If I complete the loop, then this last return is going to handle the situation. Very good, very good. And that is a solution, folks. That tests well, and that tests well. Good job, good job. Thank you very much. And yeah, folks, that is what I got for Maximum Arrays, Python, Codewars. Another code breakdown is done. So now you're armed with more knowledge, and I am too. So with that, folks, I'm good, and I am out. See you later.